This video is on how to draw molecules. Make sure that you are comfortable drawing Lewis structures or electron dot diagrams, because we're going to use those and put them together to draw molecules as they bond. So first we need to know the octet rule. This rule states that most atoms achieve stability by gaining, losing, or sharing electrons to have a total of 8 electrons in their valence level. So the gaining and losing, that happens in an ionic bond, and the sharing happens in a covalent bond. And then they can be shared equally, which would be nonpolar, or unequally, which will be polar. Some exceptions to this are hydrogen and helium. Because they only have electrons in that first energy level, they can only have a maximum of 2 electrons. So instead of the octet rule, which means 8, they have what's called the duet rule, which means 2. All right, so I'm going to go through the steps of drawing, and I'm going to do an example as I do the steps, and then we'll do a few more examples. So first you want to draw dot diagrams of your individual atoms. All right, so let's say we're going to draw NH3. This is ammonia. So my individual atoms would be nitrogen, which has 5 valence electrons based on its location in the periodic table. So 1, 2, 3, 4, 5. And hydrogen, which will have 1. And I've got 3 of them. So I've got 1, 2, 3. All right. So the next part says total up the number of valence electrons. All right, so I have 5 in my nitrogen plus 1 in each hydrogen. So my total valence electrons that I will see is 8. All right, next it says put carbon or element with the most lone, so meaning like single electrons all by themselves. So like this right here is a lone electron. Okay, the 2 up top are not. Central. So that means I'm going to look at these and I'm going to say, okay, nitrogen has 3 single electrons here, and each hydrogen has 1. So nitrogen's what's going to go in the middle. Okay. And then it says connect other atoms to central atom. And to do this means we're going to pair up single electrons. So each of my hydrogens is going to place one of their electrons next to one of nitrogen's single ones, like this. You see how I had 3 open spots on nitrogen and 3 hydrogens to fill the spot. All right, so then it's a matter of checking. So now you want to count and be sure that each atom has a full octet, right? So it has 8 surrounding it, except something like hydrogen. Right, would only need 2. So 2, right, or 8. So if I look at nitrogen has 8, right, and each hydrogen has 2. Okay, do you see like the 2 I'm talking about is these 2, just between hydrogen and nitrogen, just that hydrogen. Whereas nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 total around it. All right, the last thing then is to add them up to make sure that the total you did in number 2, so 8 in this case, matches the total you have in your drawing, which is also 8 here. All right, so let's draw a few more things. Let's just scroll down. Okay, let's do H2S. All right, so first step is to draw your dot diagrams of your individual atoms. So I've got hydrogen. Let's do that first. There's 2 of these. And then I have 1 sulfur. All right, so then it says to total up my number of valence electrons. So I have 2 here plus 6 is 8 total. All right, and then it says carbon or my most lone electrons element will go in the middle. So that's going to be sulfur in this case because it has 2 lone electrons, whereas hydrogen has 1. So I'm going to draw sulfur. And now I'm going to place my other atoms around that. So I'm going to bond these 2 right here. So hydrogen's going to put 1 electron there, and then I've got another hydrogen that's going to put 1 here. So now I'm going to do my counting, my checking. Does my sulfur have 8 total electrons around it? I see 8. Does each hydrogen have 2? Yep, each one has 2 right there. And then is my total 8 for my whole thing? And the answer is yes. So this is my structure. Now, quick thing, another way to draw this would be, instead of doing the 2 dots, you can do a single line. All right, so I could draw this like this, and the 2 dots only between things can be drawn as a line, like that. So I tend to write it this way more often, but you can do either way, and you will see both in different books or writings. All right, let's do one more example. Let's do CH3I. All right, so here's our parts. We've got 3 different things now. We've got a carbon. And carbon, in its ground state, what we've drawn before is this. Okay, so what really happens, though, is when carbon's going to bond, those electrons we talked about, ground state and excited state, they jump and fall. Well, in order to bond, they have to jump up to their excited state. So this will actually be, as it bonds, it's going to be carbon where they're going to be all spread out. All right, we'll talk about that more in class, too. You have 3 hydrogens. Oops, I'm going to do those. We'll do those green. So I've got 3 of these. And then we've got 1 iodine, which has 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to total up my valence electrons. So I have 4 with carbon, plus 3 with hydrogen, plus 7 with iodine. So I have 14 total. All right, so what is going to go in the middle? Well, it says carbon or element with the most lone electrons. Carbon has 4 lone electrons, so I'm going to draw carbon first. All right, then it says to connect other atoms to the central atom. So I'm pairing up all these single ones. So hydrogen, okay, there's one with a pair, there's one with a pair, and there's another one with a pair. And then iodine could go here. Now, here's the thing. It doesn't matter which side you put any of these on. You could have them rotated in different sides. It does not matter. It's just a matter of which direction you're looking at the molecule in. So they'd all be correct. So now I'm going to do my check. Does each thing have 8? Each atom have 8. So I look at carbon. I've got 1, 2, 3, 4, 5, 6, 7, 8. Carbon checks out. Iodine, 1, 2, 3, 4, 5, 6, 7, 8. That checks out. And each hydrogen should have 2, and they all do. So I'm good there. Now let's add them up. Do I have the 14 I'm supposed to have? So I've got, I'll do these in black. 1, 2, 3, oops, come on. 3, no, really, come on. All right, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I am good. Now the other way you can draw this is the bonds, so the ones between can be lines. So I can do carbon with a line to hydrogen and a line to iodine, but then I still have to draw these other ones that aren't bonds. We call those lone pairs on there as well. So each line equals 2 electrons. So like if I was counting up for the 14, I would say, okay, this is 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. And that is how you can draw molecules.